Okay, good afternoon. My name's Luke Bond. I'm a server developer working at Yield, or YLD, as you can see there in the corner of the slides. So, as Alex has said, I'm continuing the CoreOS theme somewhat. I'm going to be talking about a product that we've been working on at Yield that builds on CoreOS and Docker. Essentially what it is, it's called PAS, and it is something that enables a continuous deployment workflow on top of CoreOS and Docker. So sort of subtitling it, continuous deployment production environments, and that'll make more sense as we go on. So just before I go on, actually, just to get a feel for the audience, in terms of dev and ops split, who here would say they're developers rather than ops? Okay, cool. And who would say ops? Okay. Some people didn't. DevOps? Still not quite sure I know what that is, don't know where I stand. Okay, I just wanted to work in the power pose, that was all I was trying to do there. No, it's useful to know. Okay, so firstly I've only got like 20 minutes or so firstly I'm going to talk a little bit about what this platform actually is, what its problems it's trying to solve, what it does, and then have some time for a demo. But I could easily talk to you for ages about how it works, but you have to come and ask me afterwards because I only got 20 minutes. Okay, so a bit of a backstory first as to where it came from. I think in order to understand how it works, it's best to show what problem I was trying to solve and that sort of thing. So before working at Yield, I worked as a server developer at Sony Computer Entertainment, like PlayStation, part of Sony essentially. I did have logos and things on here I thought I should remove, so I just put a screenshot of a game that was being released at the time. So what we built there was essentially I should say, I worked for the part of Sony that was involved in doing back-end game servers for game teams. So they would make their back-ends and we'd write parts of them and help them with it and host them and things like that. And what we ended up building sort of last year and early this year was something like a multi-environment, multi-tenant platform to host the back-ends for these servers. So if you imagine something like, if you're an iOS developer for games, you might use something like Apple Game Center, I think it's called, or Google Play Services for Android, that kind of thing. It's something like that for first-party PlayStation titles. And we were moving from like really old sort of Java or Oracle kind of monolithic sort of structures to like a componentized architecture. And a lot of game servers were running the same code, and we had many of them to manage, so we wanted to consolidate it into one place that you could use with like an API key, that kind of thing. But the great thing that came out of this was, well, a few things I learned from it anyway, was that for developers what it ended up being was like when these guys came along, this is one of the first titles to launch on this platform, they were like, we want a dev environment, where is it, how do we access it, and then how do we deploy? They just kind of, these were really the main questions they needed answered, and we managed the thing for them. And for us it was one platform to manage, rather than many different ones that were kind of all the same, really. Like, what I mean by this is that a lot of titles use leaderboards and whatever, so we host one service of it. But essentially what we were doing was, it was like ops providing a product to developers, in a sense. So one of the main things I learned from this was that developers want a workflow and they want environments. This is kind of like why Heroku was really popular for many developers, because they love that workflow and they love that they can just very easily get things out there. Whereas ops want something that's not some crazy collection of sort of hipster tech they can't support. You know, they want something like that they know what it is that's reliable. Do you know what I mean? And yeah, like the workflow is a very important part of that. So this is all feeding into this is background for what PAS is, I suppose. So we have things like Docker, which is great, and CoreOS, which is great, and all these other things that Alex was showing on his slide earlier, conf and all these other components. But from a developer point of view, when they have like a product to ship and they want an environment, they want a platform to run on, these things aren't the things that make them excited and go, I mean, they're exciting sort of in the tech sense, but that's not what provides the workflow and the developer experience. So what you kind of need is something that ties all this stuff together And you can either build that yourself, or you can use something like we've got Kubernetes, and we've got Deis, and we've got these kind of things. And PaaS is, I suppose, in this kind of space, although it's not a direct comparison for these things. So it's basically what I'm saying is when you tie these things together is when you get this workflow, this developer experience. So onto PaaS. So CoreOS is your operating system, Docker is your unit of deployment, and Fleet is your scheduler, and then PaaS is like the platform on top of that that sort of gives, it's like an infrastructure software platform, and gives you environments and continuous deployment workflow, which I'm going to talk more about in a minute. So I just need a brief aside into, for those who are not familiar with CoreOS and Fleet and things like that, what Fleet is basically is systemd across a cluster. It's something that comes with CoreOS. So if you know on a given machine, when you have like systemd or initd and these kind of things, you start and stop services, you're doing that on a machine level. With Fleet, you're doing that on a cluster level. You're saying start 3 of these, here's the unit file for it. So PaaS leverages that, sits on top of that, and gives you these other things on top. So a few features of what the PaaS gives you. Has a really nice UI. It's been designed by John Gold, a designer in London. I'm going to show you that in a moment. You can run it anywhere you like. You can run it on Vagrant on your laptop, and you can run it anywhere you can run CoreOS, basically. So DigitalOcean now, which is great. What I'm going to show you today is running on DigitalOcean. And you don't have, there's not like special code that's required in order for you to use it. The Sony thing that I was talking about earlier did require that, but it's an in-house specialized thing. That was okay. But basically, PaaS will just run Docker containers for you. You don't need to have PaaS networking library or something like this. And from the ground up, it's been built for continuous deployment. That's the crucial thing that we've been trying to, it's one of the reasons why it was built, essentially. And with that, related is zero downtime deployments and service discovery. So if you're going to do continuous deployment, and on every commit, you're going to end up deploying some version of your services, then you do need zero downtime deployment and service discovery so that one service can talk to another without having to worry about which version it is. And you have some sort of load balancers that manage the traffic as these things come and go. So that's all sort of integral, really. And key to what PaaS is, just like continuous deployment, is having the same workflow from dev into production, so that when you're working in dev, you're doing your continuous deployment there, and then your code isn't taken somewhere by someone else and deployed. It's like you're doing the same thing. It reduces that friction to your deployment workflow. Okay, so on this workflow, just try to put together a picture of what I'm getting at. So this little brace here is showing this is what you already do, right? As Science Cat says, you're already doing this already. Basically, you do some git push to GitHub, and the webhook is triggered, and your CI runs all these amazing tests, and that's all solid, right? PaaS doesn't solve this for you. This is something you're already doing, of course. But then on top of this, at the end of that, when everything's green, whatever that means to you, you do a Docker build and a Docker push. At the moment, this is supporting just the Docker hub, but this is conceivably supporting other things. And then your image is pushed via a webhook to PaaS and is deployed, and that handles the versioning and all the service discovery and load balancing magic. So it's a very minimal imposition on your workflow is the point I'm trying to make. Push to the Docker hub and set the webhook to PaaS's scheduler, and you're in business. Okay, so I'm going to switch into a quick demo. So pray to the demo gods for me. It's not something I've done before. And also how to use a projector gods, if there's such a thing. Okay. It's a different resolution, but that's fine. Can I? Awesome. Okay, so this is the main dashboard of PaaS. And so what you're seeing here is basically 3 hosts. This is running on DigitalOcean. And one very much token service that I put on there in advance. Dillinger.io, markdown editor. Just to show you that, that this view is designed to be an at-a-glance view of what's on fire and is everything okay kind of thing. Everything's green, so that's good. And you can drill in and see the fleet states that are going on, and you can jump to some simple monitoring at the moment using CAdvisor, but we've got much more sort of advanced and persistent stuff in the works at the moment, but not for the demo, I'm afraid. And let me show you, this is kind of awkward to do backwards. Oh, brilliant. Okay. Oh, damn it. Okay, never mind. I'm going to talk to you about it. I swear it was all working earlier. This is obviously didn't pray enough to the demo gods. But basically, what we have in the services tab here is basically a catalog of your services. You create your services and link them in the sense that you enter a Docker repository for them, and you add some configuration. It has version configuration, so you will always be able to access like which deployments, what configuration was set, and the configuration at the moment is fairly basic. You can pretty much maps through to what you might do in Fig or Docker run, things like ports and environment variables and stuff like that. And you can specify whether or not it's public facing. And if you specify that something is public facing, then you get, right, so this is Dillinger service that I was running there. I've configured it with a particular domain name, but it'll just kind of prefix in like DNS the name of your service, so you can access it that way. Whereas the things that aren't public facing, then they won't set up the DNS for it. Okay. And then as I say, you set up your Docker Hub webhook, which I was going to do all live here in GitHub. I was going to edit the README file, and it was all going to be beautiful. But then I was going to demo like a basic sort of, hello world, here's my IP address, so we can see that it's round robining and things like that. But your service will appear in here once the webhook is triggered, and you can dig in and look at the monitoring and things like this. And also observe how the load balancers are giving you zero downtime deployments. This is a real shame I can't show you this. That basically gives you the gist of what it does. Yes, as I say, so continuous deployment is the main sort of motivator of how we've gone about building this, so that you can have that workflow of git push straight through to production, and you can do that straight through to your PaaS platform, and you can do the same workflow through to production. And we're using HA proxy to manage these kind of manage the load balancing for this, to give you zero downtime deployments and service discovery, and as you've seen, some DNS settings as well. Okay, so fallen a bit short because of the lack of the demo, but what we're doing with this at the moment is it's something that we've been working on at Yield for only, say, I think like 4 months or something like this, and we've got plans to release it open source very soon. Just sort of sprinting towards the Container Camp demo today, which is going to tidy it up a bit, and then it's going to be released. And you can, oh, I'm on the wrong side. You can sign up for, my cursor focus is on the other window. Okay, great. Sorry, guys. Okay, so what you can do now is you can sign up for more information here, and if you were interested in getting sort of early access and having a look at it, have a play with it, or maybe using it, then get in touch with us. You can either get in touch with me directly here, or speak to anyone from Yield, or sign up here on this page. But so our sort of plan for the coming months is to sort of tidy things up a bit, flesh it out, and we've got some roadmap features like better monitoring rather than, I mean, CAdvisor is great, but some really nice graphs and things like this. And also have some conversations with Alex the other day. He came in to visit us at work, and that's given me a whole bunch of ideas that I'm going to put in there as well. So, but yeah, so stay tuned for and get in touch and ask me. I can tell you all about how it works. And one final thing, I just wanted to say special thanks to everyone on this list that's helped get where it was today.
Are there any questions?
In all my run-throughs, I was running at about 25, 30 minutes. So I thought there'd be no time for questions, so here we go.
Thanks for the talk. Do I understand correctly that you are also providing like a private registry where Jenkins is pushing to?
In this case, no. This is hooked up to the public Docker Hub registry, so you would only push your containers there, presumably that are private. You'd have a private account yourself, so it works off webhooks from there. But I do see it as being something that people will want to add support for private registries and things like that. But currently, the open source Docker registry doesn't have webhooks, to my knowledge, unless that's changed. But we'll probably be supporting other things like this. Yeah. And
just a second question, what is the difference? So you mentioned like continuous delivery, continuous deployment and so on, but it looked like really like a PaaS solution to me, like from what I got now. So what's the difference to compare to Dice or Flynn, where you can also push something, yeah, like the proc file or like Docker images directly and then get it deployed? Yep. Taking Deis, for example, apart from Deis being much further down the line, I suppose, at the moment, but Deis takes your, I think this has changed in the last couple of months actually, but it takes your build and makes a Heroku build pack style thing and deploys it to a registry inside the cluster, I believe, and then we'll run it using Fleet from there. Whereas this is just straight out of the Docker Hub and it runs your container like so, it doesn't sort of rebuild it. That's maybe consequential, I suppose, but that's important. That's a key difference in how they work internally. But I think PaaS, Deis at least definitely markets itself as a platform as a service, whereas PaaS doesn't really see itself as that. I mean, it's early days, but see it more as you want somewhere to run your stuff quickly and have multiple environments and a nice workflow. It will give you that, but it's not, and it has very PaaS-like platform as a service-like features, but it's not striving to be a full Heroku-style thing. Is it not for production?
No, it's very much intended to be for production, but and this the sort of talk of the same workflow in dev to production is very much with that in mind. But it's not. Yeah, no, it is very much for production, but not today. Yeah.
It wasn't exactly clear what happens in between the container being uploaded to the registry and the container being deployed.
Yep.
Effectively, this new version being deployed. What exactly happens there? And another question to that as well, how do you add new servers? So if you decided to add like 100 new servers or whatever, then what do you do then?
Okay, so the second question is really, that's an easy one, I'll answer that first. The second question about how you add new servers is basically, like any CoreOS cluster, you add more boxes and you use the same etcd discovery token, and they will cluster. And then PaaS kind of doesn't care really. Fleet under the hood knows about that, and that will all be handled. So that's quite an easy one. But the former question on what exactly happens when things are deployed to give you your kind of zero downtime deployments and all that. So it has, it knows a history of deployments for each service, and it will give a new version number for the next one, and will announce it in etcd. And internally, it's using HA proxy, which is driven off this, in order to bring up the new service. Well, it recognizes the new service being brought up and add it to the HA proxy, and then when everything's kind of healthy, it will take the previous ones out. So yeah, from the options presented early in the early talk, it's the HA proxy kind of magic approach.
So I was looking at console, and there's DNS and kind of load balancing through DNS, and there you could probably do it without HA proxy there at all.
Yeah, you could do that. The reason why we didn't go entirely with DNS, and we're using it only for the external facing things, even then it's not perfect, is largely a kind of like a propagation issue. Like with HA proxy, we can immediately react to when something comes and goes, and it's going to have less instances of routing to a container that's gone, whereas if it's all done via DNS, I mean, we can tune time to live and things, at least internally, but we thought that we'd end up with sort of stale DNS information, I suppose, if we went solely with DNS. But
okay, but like, I mean, I'm talking about console, which is similar to etcd,
yeah,
which is like equivalent, pretty much. Aside from that, it just supports DNS lookup, so you could it acts as a DNS server. So
so it's something like SkyDoc or SkyDNS console has this within it, yes.
So it's like etcd, but aside from HTTP, it also has DNS.
Yeah, I guess the short answer is because we're using CoreOS and etcd, so we sort of gone down that path but there's no reason why we couldn't have used console, I suppose. But yeah, especially the key value store part of it, yeah. But that's probably the shortest answer to the question, I guess, yeah.
Hi, just a quick one. Was it written? Is it Go?
It's written in Node.js, yeah. Which is, sure, not as popular in this audience as it might be in others, but nothing's perfect.
Like, are you doing anything on top of Fleet for scheduling? Because Fleet doesn't, as far as I checked last time, is just providing some basic constraints for scheduling, but it's not very smart, I would say.
Exactly, I know what you mean. This is part of the, when I say after containing camp, we've got plans and things like that. This is one of the parts we want to address, because Fleet we're finding is really good for getting your stuff out there, deployed onto the cluster. That's no problem, but it's not something that's going to watch and say, is this up? What am I going to do about it? It will move things in certain circumstances, but I think like yourself, it's not something to be relied upon for doing your entire scheduling solution. But currently, that's what it is. But going forward, that won't be the case.
Anyone else?
Can you run many instances of PAS?
I'm sorry?
Can you like deploy PAS in different places and don't care what it does? Is it kind of passive to what it does, or PAS itself? Like, can you run many instances of it?
Oh yeah, absolutely. That's the kind of idea about having environments easily. So you can bring one up for dev, and you can bring one up for load balancing environment, another one for QA or what have you, and they're not, as long as you don't use the same like etcd discovery token or something like that, they're all separate things. There's not like a central. Like multiple instances of the PAS services running within the same cluster.
Yeah, how does it interact with the with Fleet and etcd? Is it kind of passive? It just sits there and presents the data, or is it actually doing some work there?
You can only run one instance of the services of PAS's internal things. If you ran more than one, then that would make a problem.
So but they do stuff, right? They're not passive. Okay.
Yeah.
So I was thinking it may be just passive, like, and then. Okay,
yeah.
Cool,
Yeah.
thanks.
I mean, at least as things stand at the moment, anyway. I think one more. I think I'm a minute or two away from time.
About 8 minutes. You probably take another 2
Brilliant.
Do you have any support for sort of a pipeline approach? So, for example, if you want to do continuous delivery to a development environment, and then you maybe had a manual QA environment and a UAT environment, and then a production environment.
Yep. Short answer is no, not at the moment. But later on today, there's a talk by a guy named Andrew talking about continuous delivery, continuous deployment, and he knows a lot more about these things than I do. But at the moment, it's designed to, at the end of your continuous deployment pipeline, it'll get deployed. But the exact details haven't been figured out in terms of when you go from, like, do you go from one into another pipeline, like you say, or do you just sort of redirect your webhook? I imagine you'll probably have, at the moment, my current thinking is that you probably have multiple webhooks going to multiple environments, and that will work fine even as it is with no changes. So you can have your sort of dev environment and your production environment. It's probably not quite what you want, but
the exact answer to that, I suppose, is unknown at this stage. Yeah.
Anyone else?
Hi, hello. I was just wondering, the Dillinger app you showed was obviously like a client-side app. How would you go about handling state, like with a database?
Well, there is some state in some of the PaaS services themselves, like the database for the services. And at the moment, we're using volume mounts to make sure that that's persisted to disk beyond the lifetime of the container. And also using, through etcd cloud config, you can use metadata to say that, to tag boxes as maybe you might use them as types. We're using that, for example, to say that this particular box is where persistent things go. And we'll mount all our volumes there, and you'd sort of back that up and things like this. But this is a fairly, that works. It's reliable enough for web PaaS today, but you do something probably more robust as you would do anything else running containers in production with persistent storage.
Sure, thank you.
Yep.
Next.
Okay.